Okay, I'm going to go through with you 6 of the most common circle theorems that are likely to come up in your GCSE exam. Okay, first one we're going to look at here is an angle in a semicircle is always 90 degrees. What you have to be careful of is the fact that you need a diameter for this theorem to work. Alright, so if we're looking at the line that goes from A to C, we've got a diameter there. Now normally they would indicate it's a diameter by having a dot in the middle of it, but they haven't on this example, but look for that in your exam. Okay, so if you have a line, a diameter there, and you join each end of it to a single point on the circumference, then you're always going to get a 90-degree angle there. So I can move point B anywhere around the circumference and it will always be 90 degrees. In an exam question, what they might do is they might give you an angle here at C and ask you to find the angle at A. So what you'd need to do is use that angle and the 90-degree angle, take the sum of that away from 180 in order for you to find the angle at A. Okay? Next one we're going to look at here. Okay, sometimes they call this the arrow, but the angle at the centre is twice the angle at the circumference. Now what we've got here, okay, if we have point D and point B, and we join those 2 points to the centre, and also a point on the circumference, that's what creates this circle theorem. So you've got 45 degrees at the circumference and 90 at the centre. If I change that angle at the centre, alright, make it a little bit smaller, make it about 60 degrees, you can see that the angle at the circumference is now 30 degrees. Okay, and wherever we move that around, that'll be 30 degrees. Just be careful because this looks a bit like another theorem that I'm going to show you in a minute. But notice that we have a point on the circumference and the other point is at the centre. What I'm going to show you in a minute, both points are on the circumference. Okay, so the angle at the centre is always double the angle at the circumference. Okay, this is the one I was talking about. Here, okay, we have angles in the same segment are equal. Now if we start at D and just have a look, if I go to D, up to C, down to B, up to A and down to D, it's a little bit like drawing that house with a cross in it without taking your pen off the paper. If you can do that, then we've got angles that are going to be the same in the same segment. Okay, now you can see that A and C are the same, but also D and B would be the same as well. And if we adjust that, as you can see now, I've made the chord, put the chord in a different place. We've got 61 degrees in both A and C, wherever we put them. Again, it's not like the arrow that we looked at a minute ago. Both these points are on the circumference and not in the centre. Okay. Right, what we have here is a quadrilateral inside a circle, and this is called a cyclic quadrilateral, or some people pronounce it a cyclic quadrilateral. The properties we have here is that as long as all the points are on the circumference, and again be careful, we've got all 4 points here on the circumference. If you look, the opposite angles, alright, 70 and 110, that adds up to 180, and 180 add up to 180, okay, and we can move those around, change them, and as you can see, whatever we've got will add up to 180. So that's the circle theorem there. Opposite angles in a cyclic quadrilateral will always add up to 180 degrees. Okay, this one here, we have a fixed point outside of your circle, a bit like the moon, and this is a bit like the Earth. Alright, and if we take a line from that point and create a tangent, now a tangent is a line that just touches the circumference of the circle, alright, and we take another line that just touches that side of the circumference of the circle. What that creates at that point is a 90-degree angle. But the circle theorem that we're looking at here is the other 2 angles inside the shape, the 39 degrees at P and the 141 at O, they will add up to 180 degrees. Okay, so if I just put some nice numbers there, 40 and 140, that's 180 degrees. 30 and 150 is 180 degrees. And these lines here, they indicate that these lines are going to be exactly the same length as well. Okay, so if you're looking at that theorem, remember a bit like the cyclic quadrilateral, the opposite angles here will add up to 180 degrees. Okay, last one here. We've got a triangle here with a tangent, triangle within the circle and a tangent outside. Okay, the colour coding helps a lot here, alright, but looking at the tangent, if you look at this 68-degree angle here, you'll also see there's another 68-degree angle inside the triangle. Alright, and what I tell people to look for is look at the lines that 68-degree angle is created by and follow the line in the triangle that it's not created by, and when you get to the top of that you'll see that it's 68 degrees. Same with the 45-degree angle. If you can see the line here that creates the angle, if we follow the one that doesn't create the angle, that's where we find our 45 degrees. And I can change those angles, move this around, and you can see that the green angles will always stay the same and the red angles will always stay the same as well. It's just a bit tricky spotting them, but as I said, look for the line that it's not created by, follow that up to the top, and that's where you'll find your angle. Okay, I hope that helps. There's some questions on this that I can tweet from @Mr. Toyer Maths, and you can have a little go at some of those. Okay.